Hey, how's it going, everybody? You've seen a video of this before. This is my basically proof of concept two-spark, two-stroke. Now, this one had the advantage, this particular cylinder, is because the existing spark plug hole, which I think was, yeah, this one was already on a slight offset, which is interesting. So it wasn't dead center over the cylinder, so that gave me room to actually drill and tap the spark plug basically reflected on this side of the cylinder, which was interesting. This is extremely consistent spark. It's got a real even burn, and it just feels, I can't really explain it how it feels, but it feels different. And what I mean by that is it feels like it just feels different. You'd have to try it and build it for yourself to see what I'm talking about. It almost feels more balanced, the best I can describe it, more even. Again, my initial hope with this proof of concept, at least on this one for the two spark, was to I'm trying to reduce engine short circuiting in two strokes. Once I accomplish that, and once I'm able to measure that accordingly, then I'm going to move to the exhaust side of things and see what I can do to save on emissions. Because short circuiting is a big problem in two strokes. Reason basically for most of the emissions for these engines. Idling these engines lose 70% of all the energy generated by the heat. So they're inefficient engines by that standard. Obviously they're the most powerful for their size, but short circuiting basically is the amount of gas and air mixture that's just escaping out of the exhaust because it's not burned. Basically there's a small amount of time when the exhaust port is open and the fluid is there before it sparks, where it can go out. Another thing that happens is it's an incomplete burn, so the leftover escapes out the exhaust by way of emissions, and two strokes are just notoriously bad for emissions. One of the statistics is that a two-stroke running for about an hour, let's say in a weed whacker, is the equivalent of a modern fuel-injected car running for about 900 miles. I read that in a book, so the California lab did a study on that, so that's fascinating. So I'm trying to reduce emissions, taking that proof of concept and applying it to my next cylinder. Downfall of this cylinder is that the spark plug is directly over top of the inside of the cylinder. Now this particular cylinder, the top hemisphere is basically a third of a sphere, taking it from the top, moving towards the center of it. So the downfall, or the hard part about this one, was that I had to, well, first you have to remove some of the shielding fins. So you do lose out on some radiation, heat radiation. So I might spray paint this black to gain from that very small gain you can get by painting it with black enamel. I might do that. But you can see, if I get under light here, you can see that my spark plug, the second one at least, is, I have to measure exactly, but it's almost the same height. Now the reason I put on this side is because it's opposite to the exhaust port. So my hope is that I build a lot of back pressure in the rear of the inside cylinder, or the rear of the cylinder, to create back pressure to basically and this is where I have to test, because I think this one's going to fire first, because I think it's going to be, or sorry, not fire first, but it's going to, I think I might, I don't know if see, this is where I'm kind of stumbling, because I have to figure out what I'm going to do exactly, but I have to put one of them a little bit further down than the other, so that way when they both ignite, the one's igniting the fluid first and then the other one. And the reason for that is because you want the second one to ignite what's left over to reduce short circuiting and help on emissions. So I want that to be this one on the left that fires or fires on the remaining mixture. And I want that to happen on this side of the cylinder because I don't want to create pressure on the same side of the exhaust, because then you get a weird airflow. I want it to be on this side, so that way when as this piston's going down, we have this pressure system on the left side if we're pushing out the exhaust to the right. And I need to mess with the nozzle because I have to angle see, I want to angle the exhaust a particular way. I don't quite know yet. I think I'm going to have it go up like this on the outsides, so that way we're building pressure in the right way. The only thing I'm thinking about is, see that middle fin in the middle? I don't know. That's an interesting design. I don't know what we're going to do about that. I might make that thinner, if anything, to reduce friction. And there's also a lip, you can see that in the middle. That's not really going to mess with pressure by them putting that there. It will a little bit, but I might flatten that just to open the exhaust port up. And that might be the only thing I do starting out. So I might remove that bottom lip there, so that way the exhaust, at that point the exhaust will remain open longer. More air will escape, but I'm not sure what I'm going to do for that middle fin there. Can't mess with intake timing in this one because intake is in the bottom crankcase. So this is what I have so far. I'm really fascinated by the effects of this because it's not a very common, it's not, well, I don't see it anywhere on handheld two-strokes for that matter. You can find some dirt bikes or some of them that come with a dual spark two-stroke, but they're usually a little bit bigger. So I'm really interested to see the effects of this on handheld two-strokes. So this in particular is like a mid-40s cc saw that this came on. So yeah, I gotta do a bunch of research, and I right now I'm messing with the base gasket gap. Basically I want to basically increase the total volume of the cylinder plus the crankcase to allow more air and fuel inside. I have to calculate the volume first when I increase it. Now when I say increase, it's about a millimeter, or not even a tenth of an inch, or not a tenth, a 16th of an inch. I have to figure out what that'll do to my volume, so I'm currently working on that, but I'll make a video when I post that up. So but again, I'm primarily focused on emissions, and I want to make these better, so I have to figure out a way to measure that accurately. But anyway, thanks for checking that out, this video out. So I'll be posting some more stuff later on. Alright guys, I'll see you.